Okay, here we go. Second lesson of the chapter. Pyramids. Here is your homework. Okay, pyramids. As I stated in the previous class, during this chapter, you get a shape and you're going to get two formulas. The formulas, one's going to be for surface area. The book likes to call that total area. Either one you can use. And then for volume. And I will say pyramids, um, although the formula is pretty straightforward, the application of it, typically these are going to be much more challenging than the previous shape. All right, so we'll start off with the basic definition of a pyramid. Well, it's three-dimensional. It's made up of polygons, so therefore it's a polyhedron. So a pyramid is a polyhedron with its base, the bottom of it, being a polygon, and the sides of it being triangles. And those triangles will all meet at a single point at the top. Okay. So the key points there is the base is a polygon and the sides are triangles. Many parts of it. Let's go over them one by one. Now, since the base is a polygon, it didn't say it's a square. It doesn't say a rectangle. It could be any polygon. Here's a pentagon right here. All right, so let's see. Major parts are number one, the base. And the base is that polygon that the lateral faces, the sides, all share a common side to. So let's see, which side do they share? For instance, AB right here would be shared with this triangle right here. I drew that kind of crummy, but you get the idea. So there's the triangle. And I'll do it in blue this time. What edge does it share? It shares this edge right here. Okay, so that's what the base is. Generally, we don't see pentagons. We generally see squares or triangles. Second part are those sides, the triangles. Those are called the lateral faces, and the lateral faces are always triangles. Maybe the number one shape that this is confused with for students is the triangular prism. The triangular prism does have in fact two triangles, but the sides are rectangles or parallelograms, whereas for a prism, the sides are always just triangles. So the total number of rectangles that you could have on a pyramid is one, whereas on a prism, you could have lots. Where do the triangles meet? They meet at the top, and we call it the vertex. As always, you can pause this. And let's see, if I measure the distance between the base and the vertex, we call that the altitude. And yes, it will be abbreviated H. We use the word altitude for three-dimensional shapes, height for two-dimensional shapes. But since A is also used for apothem, that's why we use this H, even though altitude is for three-dimensional objects. Here is a hexagonal pyramid. Previous one was a pentagonal pyramid. The one on the left, pentagonal. The one on the right, hexagonal. And if we look at the one on the right, we get our last thing that we need to write down. Now, I like to write this with a cursive L. The book uses italicized L, and it sure looks like a 1 to me. That isn't a 1, that's a italicized L. And think about it. If the sides of a pyramid are a triangle, and if you looked at that triangle and you measured the distance from the base of the triangle to its vertex, well, that wouldn't be the height. That would be a different distance. We call that the slant height. It is abbreviated L, though. So the slant height is that perpendicular distance on one of the triangles of the pyramid, and that's a measurement from the bottom of the triangle to the top. Okay, so there is our vocabulary words. Just like we had types of prisms, we're going to have types of pyramids. Now, obviously, the first main type is the name of the pyramid. There's a hexagonal pyramid. But if we talk about the relationship between the vertex and the base, if the vertex is directly above the base, in other words, if you can find the center of the base, that's that point O right there. And if the vertex of the pyramid is directly above it, we call that a regular pyramid with one extra additional caveat. The base has to be a regular polygon. So if the base is a regular polygon and the vertex is directly above the center of that polygon, then we call it a regular pyramid. Few consequences. That means where the two triangles meet together, or all the triangles meet together, the vertex, if you go straight down from the vertex to a vertice of the base, I'll highlight one for you. If I go, and this is in red, if I go from the vertex down, this right here is called a lateral edge, and the lateral edge, they're all congruent. So all the lateral edges are congruent. All the triangles are going to be isosceles. Since all the lateral edges are congruent, therefore each triangle is isosceles. And as previous mentioned, the altitude is from the center of the base to the vertex. So that is a regular pyramid. So what is an irregular pyramid? We don't call it irregular, but if I were to move the vertex left or right, or forwards or backwards, maybe move it a little bit forward or a little bit backwards, well, then it now no longer would be directly above the center of the polygon, and we would get something that looks like that. And that is called an oblique pyramid. Luckily for us, we're only going to be messing around with regular pyramids today and in this chapter. So oblique pyramids do exist. We're just not going to mess with them. There are formulas for oblique pyramids for surface area, and there is one for volume. But if you ever have to calculate the surface area of oblique pyramid, you'd have to do each side, including the base, separately, and then add them all together. But we will get one formula for any regular pyramid, and that's what we'll work on next. All right, so the first game is we're going to calculate the slant height. Remember, the slant height is the perpendicular distance along one of the triangles from the bottom of the triangle to the top, abbreviated L. There are two methods. I'm going to show you both triangles, or the two methods here in colored form right here. Typically, you're going to be given a pyramid where that yellow triangle is not outlined in front of you. So they're going to ask you to calculate the slant height. Well, you've got two options. There are two triangles that you can draw along any regular pyramid that would include the slant height. There's the first one in yellow, and then the second one would be in blue, and both of those triangles would include that L. So it just depends which one we have information on. Do we have information on the yellow one, or do we have information on the blue one? Well, let's see. Here's the start. If I were to calculate L right there, I'll outline this for you. If I were to calculate L right here, well, that's part of this triangle right here. And that triangle only has labeled the 5. So if you only have one thing labeled on that triangle, you're not going to calculate the second one, unless we knew an angle or something, we could use some trig. But we don't know that. So we're going to have to go to option number 2. And option number 2 is go to that blue triangle. Or I should rather say half of that blue triangle. So there's the blue triangle right there. I just redrew it there on the bottom. But we know from the given information that the lateral edges are 13, and it's regular, so all the lateral edges are 13. And we know that the base there is 10. And since that perpendicular is a perpendicular bisector, it would cut that 10 in half. And now notice, if we're trying to calculate the slant height would be that dotted line right there. I've got two right triangles, and each right triangle has two sides. I can use the Pythagorean theorem to find the third side. So 13 is the hypotenuse. So L squared, that's the slant height, plus 5 squared is equal to 13 squared. Just do that little bit of math right there. Subtract 25, take the square root, and we get 12. Okay, so the slant height is 12. Different problem. We did not just calculate the dotted line at the altitude right there. The previous one, we were calculating the slant height. So I'm using the same shape, just with different numbers to do a different problem. Okay, so remember I said there were two ways, the blue triangle or the yellow triangle. So here's an example of where I could calculate the slant height of the triangle there or the pyramid right there using the yellow triangle. So notice now on the yellow triangle, I have two of the sides listed, 5 and 12. So just straight up Pythagorean theorem again. So this time a little bit different number answer. 144 and 25 is 169, and the square root of 169 is 13. So there's your two examples. Rewind if you need to. Two examples of how to calculate slant height. It's going to be one of those two triangles, either the blue one or the yellow one. And then I'll just say it one more time. When you're presented with the pyramid, those triangles will not be drawn. You will have to draw those two triangles yourself. All right, so the second game is, well, let's calculate the altitude or the height. So that's labeled H there in this pyramid. And check this out. Look, again, we run into the same problem. Well, if we look at the yellow triangle right there, and I want to calculate H, I only have one side. Once again, there's two possible triangles here, but the second one has nothing to do with the height, but it will calculate the slant height, and that's what we need in order to get to the second side of that yellow triangle. Let me explain that a little bit better. The yellow triangle right here, we only have one side length, and that's 5. If I could somehow calculate what L is, well, then I would have two of the sides, and I can use Pythagorean theorem. So how do I calculate L? Well, I go to the other triangle in red here. I better do it in blue. The other triangle here in blue, which is this triangle, VBC. And VBC has two of the sides labeled, 5 and 13. And it's the same math that we did before. Just use those two values in order to calculate your slant height. Okay. So your slant height there is, let's see, 13 squared is 169, 5 squared is 25. Subtract 25 from both sides. Square root of 144 is 12. We did this before. Okay, so now I can plug the slant height in to the formula there on the left, which is the yellow triangle, what we needed to calculate H with, and just go to town on that. So let's see, 5, 12. Well, maybe when we do the math there, let's see, 144 is 12 squared, 5 squared is 25 squared. Subtract 25, and we get, 119. And I'm pretty sure 119 is a prime number. Therefore, there are no perfect squares in there. Expect your problems tonight for homework to be as challenging as the ones I've shown you, where most of the time you don't get to an answer without doing multiple steps. If it helps to draw the triangle you're trying to calculate off to the side, as I did right here, notice both instances, I just simply drew a triangle off to the side just to help me visualize it. Absolutely do that. Okay, what else we got? I gave you two answers there. So 119 is the exact answer. If we plug that into our calculator, that's about 10.9. I'm rounding to the nearest 10th. Read the instructions for homework, and it will tell you what you need to do, whether it's exact answer or they'll say round to a decimal. Okay, so we're in, yes, I'm using the same triangle over and over and over again. So now we're going to calculate the lateral area. So let's think this through, the lateral area. Well, it's a regular pyramid, and so we know all the triangles have exactly the same area. They're all congruent. So all I really need to do is calculate the area of one of those triangles and then multiply by how many triangles we have. Okay, so if we go back to our friend, the blue triangle, remember that was VBC. So the blue triangle is VBC, and the area of a triangle is base times height. Well, I got a base. The base is 5 plus 5, which is 10. And no, I'm not going to do that calculation again for slant height, but we found the slant height was 12. Therefore, I can use that for base and height of my triangle to find that one area. So let me get caught up. So there's my 5, 12, 13 triangle right there. So the area of one of those triangles, base times height, the base is 10. It's not 5, double 5 is 10. The height is 12. 10 times 12 is 120. So divided by 2 is 60. And how many of those triangles do I have? Well, it's a square pyramid. So therefore, there's 4 of them. So therefore, I need to take that answer 60 and multiply by 4, and that would be the side area or lateral area. So 240 square units. All right. That seems like we could get a formula out of that, and we will. So let's think about what we just did. Well, let's think about the numbers we plugged in the formula, right? Easier way, absolutely, there's a formula. So let's see, we plugged in 10. 10 was the side of the base of the pyramid. 12 was the slant height, and divided by 2 was divided by 2. But when we got that answer, which was 60, we multiplied by 4. What's 4? 4 is how many sides you have. It's also how many sides the base have. And so if we think about what I just labeled there in green, 10 and the 4 that we have to multiply together, that's the perimeter of the base. So instead of writing that BH over 2, instead, the lateral area could be written as the perimeter times the slant height. Remember, that was what 12 was, and then divided by 2. And that will give me the entire lateral area. And that actually, we just proved that, and that's our next theorem to write down. So theorem 12.3 just states what we just proved. And what we just proved is that the lateral area, now this is only for regular pyramids, is equal to half of the perimeter times the slant height, or PL over 2. Okay, so we were able to prove that one. Great. The but here is that, well, that's not the total area, because the total area would need to include the bottom, and the bottom is a base. So if you remember from the previous lesson, the base area is a capital B. So lateral area plus B, but wait a minute, we just figured out the lateral area was PL over 2. So there on the bottom, drum roll please, that is the formula. Now, why don't they write that as a theorem? I'm not sure, but they don't. So surface area or total area of a, and this is only for a regular pyramid, the total formula for total area is equal to PL over 2 plus capital B, where capital B is the base area. Okay, this is not a proof, and we can't prove this until calculus. But here's a quick video. Let me start that again. There's a quick video. So let's see, what has he got? He's got 3 pyramids. And when you put the 3 pyramids together, it makes a cube. So 3 pyramids, or the pyramids regular. Let's look at the bottom of them. He's going to flip it over here in a second. And there's 1, 2, 3, and they're square pyramids, so they're regular. So 3 regular pyramids, when you put them together, you make 1 cube. Well, then therefore the formula, right? The formula for the volume of a pyramid would be the volume of the cube divided by 3. So if we use the base area, multiply it by the height, that would be for a rectangular prism, that would be a cube. And then if we divide by 3, we get to one of those pyramids. Okay, so I technically did not prove that. This is a theorem. When you take calculus, they will prove that theorem for you. Okay, and now we got to do some examples now. By the way, we have the formula for surface area or total area, and we have the formula for volume. Now all we're going to do is an example. So obviously it's high school. They're not going to give you a nice 8th grade easy example. It's going to be more challenging. So there's my pyramid. We're going to calculate both the volume and the surface area, but we'll do volume first. And as always, volume is the easier of the two. So let's see, what's the formula for volume of a pyramid? We just wrote it down, and that's BH divided by 3. And why do I say UG? Because capital B means base area, and check out what we got for a base. It's not a nice, easy square. This one's a hexagon, but it is regular. So we need to figure out the area of that blue shaded area first, and then multiply by the height, because the height there is listed as 12. All right, if only 6 was the area, but it's not. It's the side of that hexagon. But we've done this before, previous chapter. You just took a test on it. So there's the 12 in the right spot. We just need to come out with capital B, and we're done. The base area of a regular polygon, remember, we have a formula for it, and that is AP divided by 2, or 1/2 AP, or PA. And we've done this problem many, many, many times before. In fact, you might remember that the angle in the center there, 360 divided by 6 is 60. The side is 6. So if we come up with the apothem, right, Perimeter of that hexagon is 6 times 6 or 36. We just need to figure out the apothem. Remember, the apothem is that dotted red line right there. And if we cut 60 in half, we get 30. So it's a 30, 60, 90 triangle. Cut 6 in half, it's 3. Well, 3 would be your A or your X value right here. And the apothem will be X times root 3 or root 3 times X. And since X is 3, then the apothem would be 3 root 3. Plug that into my formula there to the left. So base area would be apothem times the perimeter divided by 2. We just figured out the apothem was 3 root 3. So we need to do 3 times 36 divided by 2 and attach a root 3 on it, and that's 54 root 3. So finally, back to our original formula. Remember, our original formula was right here. We plugged in the 12 already, and now we have the B value that we can plug in for B. Let me erase all that. And now let's do that. So B is 54 root 3 times 12. Ooh, that's a big number. You could divide 12 by 3 and get 4. And 4 times 54 would be what? 216? Yeah, 216 root 3. And I did not put square units, but I should put square units. So easy, medium, hard. This is definitely not easy. This is more medium. I don't know if I would consider this one a challenging one, but this is definitely not an easy one right here. If you didn't get it, rewind, play it again for you. Okay, if there is a triangle that will cause you problems, or sorry, if there is a pyramid that will cause you problems, it's the triangular pyramid. So here we have a triangular pyramid. The base is on the bottom there. And somehow we're supposed to come up with the lateral area. So that means, well, there's going to be 3 triangles, and it's regular, so they're all congruent. So we got to do base times height divided by 2, and then multiply. Oh, wait, no, we have a formula, remember? P for perimeter times the slant height divided by 2. So the formula that, why is this not clicking? There we go, PL divided by 2. The problem is there's no side lengths listed at all. There's also no slant height. So when we look at this problem, your eyeball should focus on the values that you do know. We know 2 values, 10 and 6. And if I were to highlight it in blue, let's see, the 10 would be the hypotenuse of this triangle right here in blue. 10 is the hypotenuse and 6 is the long leg right here. Okay. All right. So let's see, if 6 is the long leg and 10 is the hypotenuse, can we use that to our advantage? Well, we can find out this value right here just using Pythagorean theorem. So let's do that. All right, so maybe that gets us to an answer. Maybe it doesn't, but we can at least calculate that value, right? So let's see. I got nothing other than that one little piece. So that one little piece of that triangle right there, I drew it for you. Let's see, 10 squared will be equal to 6 squared plus x squared. 6 squared is 36, 10 squared is 100. Subtract 36 from both sides, 64. Square root of 64 is 8. So that little piece there, I just highlighted it, there is now 8. Okay, I still need the slant height. How am I going to get that? Now, here's the leap of faith, and this is typically something you probably wouldn't have noticed. If we look at the bottom of the triangle, that's triangle ABC, and we know it's regular, well, therefore, we know a regular one means all the sides are the same. It means it's an equilateral triangle on the bottom. So if it's an equilateral triangle on the bottom, that means that dotted line there that goes from A to M has got to be a median, right? Because it's equilateral triangle. And if you are perpendicular and you go from a vertex, then it's a perpendicular bisector. We have that one theorem that states that. So if it's a perpendicular bisector, well, then perpendicular bisectors go through the centroid. And this is coming from last chapter. And if you can remember the centroid, right, of that triangle, 2/3 of AM is going to be equal to AO. So 2/3 of AM is AO. Well, I don't know what that is, except I do know AO. AO is 8, and I could solve that now for AM. Well, let's see. Do a copy dot flip on 3 and multiply both sides by 3/2. 8 times 3 is 24. 24 divided by 2 is 12. Therefore, I know AM is 12. And since AO is 8, 12 minus 8 is 4. Oh, thank heavens, I now know the bottom of that triangle where I'm trying to find the slant height. The bottom is 4, the other side is 6, and now I can use Pythagorean theorem to calculate the slant height, which I need for my formula. So let's see, 6 squared plus 4 squared, that's 36 plus 16, 52, square root of 52. Let's see, 4 goes into 52, what, 13 times? Yeah, 13 times, so 2 root 13. So the slant height that I can now throw into, if I want to, that I can now throw into this L right here is 2 root 13. I just need the perimeter. So how are we going to find the perimeter? Well, more work, as always, more work. Let me clear that out. So let's see. So let's see if we can find the perimeter. I just threw in the 2 root 13 for the L. I need to now find the perimeter. Those 2's cancel right there. So we're just left with perimeter times root 13. So what's the perimeter? Pick any one of those triangles. I'm just going to pick that one. We know the slant height, right? Remember, was 2 root 13. We know that all the lateral edges are 10. Remember, that's one of the things that we had, that on a regular pyramid, all the lateral edges are equal to each other. So we know the slant height was 2 root 13. We know the lateral edge was 10. Once again, I have two sides of a right triangle. I can solve for the third side. So 100 or 10 squared is equal to x squared plus 2 root 13 squared. If you square 10, you get 100. If you square 2 root 13, that would be 4 times 13, or 52. Subtract 52 from both sides, and we get 48. Take the square root of 48, that's 16 times 3, and the square root of 16 is 4, so we get 4 root 3. Wow, that was a lot of work. So here's the deal, though. Remember, we only solved that for CM. That was our x. So that's 4 root 3. The other side is 4 root 3. So one side of the pyramid on the base would be 8 root 3, but there's 3 of them, 3 of the sides. So I need to take 8 root 3 and multiply by 3, or 24 root 3. Wow. Okay, what do I do with that? Well, I got to take that value right here and toss it way back over here to where my P is, and then just simplify. Let's see, root 3 times root 13 is root 39, and there is no perfect square in root 39, so that is the answer. As I stated before, this one is a truly challenging one. And I'll just say this, the reason why this was truly challenging is not necessarily for most of it, but for the 2/3 part. That part where we remembered that AM is a median, that was the thing that gave it away. So when it was a median and it broke it up to 1/3, 2/3, if you didn't recall for that, then this is almost an impossible problem without some angle measurements. Okay, I think that was a problem that is a good place to take a deep breath on. But let's see, that was the volume, or that was a lateral area, or did we do lateral or total area? Oh, that was just the lateral area. So if we were to do total area, then you would have to do base times height, which we could. The base would be 8 root 3, the height would be 12, and then add that to our answer. But instead, we're going to do volume here. Okay, so the volume, remember, is base area times the height. And as I stated before, the base area, we just figured out that AM was 12. The base was 8 root 3. That means any side is an equilateral triangle on the bottom. So any side is 8 root 3. So CB, side CB, is 8 root 3 also. And so we just simply need to do that for my base area. The height of the altitude of the pyramid itself is 6. So now let's plug in the base area. So 6 divided by 3 is 2. So the base area is 8 root 3 times 12 divided by 2. Let's see, 12 divided by 2 is 6. 6 times 8 is 48. So we get 48 root 3. Toss that into my B, so we get 96 root 3. And volume is always in cubic units. Not all the problems are as hard as this one, but I did want to end on a much more challenging problem. And that's it for today. Just remember, any picture you see with shading for homework, it is in 3 dimensions. And, well, the entire chapter is in 3 dimensions. Remember that little italicized L means slant height, LA lateral area, V volume. And that'll do it for today. If you run into any problems, don't hesitate to ask me a question. I'll post a video. I got to make the video, but I will post a video as soon as I can. And that will wrap it up for today. Have a wonderful day.